x is our slope function, right? So if our slope is positive, we know that our function has to be increasing. Fernanda, if f prime is negative, then what do you know about f of x? F of x is decreasing. Okay, and then Tyler, if f prime is 0, then f of x is doing what? And what do we say in mathematically for something that stays the same? Yeah. Ooh. Help him out. What'd you say? It's constant, right? So if it's not changing, then we say it is constant. Does that seem okay? Okay. I'm going to give you a little more time to answer these two questions. I want to be really clear. One says, here are 3 curves. What is true of their first derivatives? Your answer should be the same. You should have one answer for what is true of all 3 of these first derivatives. Does that instruction help clarify what I'm asking you to do? So think, okay, we have these 3 curves. There's something true about all their first derivatives. So all their first derivatives have something in common. What is that? Answer 2, and then try the what do we know so far 4 and 5. Let's see. Ethan.
Yes.
On 1, we had these 3 curves. What did you say was true about their first derivatives?
They were all positive.
Why are the first derivatives all positive?
Because the slope is increasing.
Ooh, I disagree with that.
Oh, wait.
What is increasing?
They have a mix.
The functions are increasing. So f of x is increasing, which means f prime is positive. Does that seem okay? Because an increasing slope, one of those actually has an increasing slope. The middle one has an increasing slope. But that one's slope is constant, and that one's slope is decreasing. So we just have to be really clear that we're saying f prime is positive because that means f is increasing. Okay, Hilton, what is true about the first derivatives on these 3? Why? What? Good. And really, I think that this trying to be really clear when we're talking is, I think, one of the hardest things about what we're doing right now. Okay. For a function to have a relative maximum, what must be true of the derivative? And this, I don't know, I didn't look at a ton of people's answers. Some people have things written down, some people don't. Does anyone think, what did you just whisper, Ethan?
I said it needs to be positive and negative. Because at first I said it needs to be going up then down, but isn't that just the functions going up and down?
Okay.
So the derivative would have to be positive and negative.
I absolutely love that. So if we talk about a maximum, a relative maximum right here, we know that f goes from increasing to decreasing. And if f goes from increasing to decreasing, then f prime goes from positive to a negative. Are you okay with me just abbreviating positive with a plus sign and negative with a minus sign? Okay. So, similarly, we're going to look in a relative minimum. What is our function going to do?
Go from decreasing to increasing.
Okay, so f goes from decreasing to increasing. And again, I'm just going to abbreviate decreasing and increasing. And if f goes from decreasing to increasing, then what do we know about f prime?
It goes negative to positive.
Okay. Yes, sir.
Then What's the difference between just a maximum and a minimum and a relative maximum and a relative minimum?
You know, that's a great question. We'll have a conversation about that in a little bit, actually. Yeah? So right now, I just want you to focus on relative maximums and minimums. So relative maximum is the highest point, like, of all the points around it. So it's going to be a peak, right? And it doesn't have to be a curved peak, but it will always be a peak. And a relative minimum will always be a valley, where it is the lowest point of all the points around it. As far as like, and the other term we tend to use is either like absolute maximum or global maximum, or like a maximum on an interval, and we will talk about those in a smidge. Does that sound okay? Okay. So here's a definition. This is new vocabulary for us. A critical point is a point where f prime of x either equals 0 or does not exist. So a critical point is a point, meaning x and y, where our derivative either equals 0 or our derivative does not exist. A critical number is the x value of that critical point. So when we talk about critical numbers, we're talking about our x value, where our derivative either equals 0 or does not exist. And then a critical point is that actual point. Does that seem okay? Okay, so let's look here. What I would like you to do is I want you to actually try doing A, B, and C on your own. So just pausing. A asks you to find the critical numbers of f. What's the first thing you're gonna have to do?
Find the derivative.
Find the derivative, and then we wanna know when that derivative either equals 0 or does not exist. A hint to you on B is that I did A first for a very specific reason. So if you know where your derivative equals 0 or does not exist, that should then help you figure out your intervals where f is either increasing or decreasing. Try doing A, B, and C. If you struggle with B and C, that's totally okay. We'll go. What was your first step to finding the critical numbers of f? And what was your derivative?
4 minus 2x.
Okay, once you found the derivative, what'd you then do? Yeah? What did you then do?
Subtract
So negative 4 equals, a negative 2x?
Yeah.
Okay,
And then I divided the -2 over. And then I got 2 equals x, or x equals 2.
okay, I agree. Our critical number here is x equals 2. Now, to answer B and C, we're gonna do something that I think most of you did last year, but it's possible some of you haven't actually done. It says determine the intervals where f of x is increasing and justify your answer. If I say sign chart, is that vocabulary familiar to any of you? No? Okay, so let's pause and think. We know that our derivative is 0 at 2, which means that we know, well, we don't actually know it changes there, but that's a possible point for where our derivative will change from positive to negative or negative to positive, right? To switch signs, you have to go through 0 or does not exist first. And so we're gonna use this to set up a number line where we can then figure out where is f of x increasing and where is f of x decreasing. So what I want you guys to do, even if you answered B and C, I want you to do it this way. I want us to add in a sign chart. And an important thing, a sign chart doesn't count as a justification on the AP Calculus exam, but it is a very, very good way for us to organize our work. So we're gonna look at x equals 2. I'm gonna put 2 on my little sign chart. And what we are caring about is we wanna look at values of what? Do I wanna look at values of f or of f prime? Why do I wanna look at values of f prime, Ethan?
Because we're dealing with increasing prime, or no, because it's
So when a function is increasing, what do you know about f prime?
positive.
And when a function is decreasing, what do you know about f prime?
So
It's negative. So what we wanna do is figure out where is f prime positive and where is f prime negative. So I'm gonna write a little f prime here, just to remind myself that what I'm actually looking at is gonna be signs of f prime. What's a number that's bigger than 2, guys? 3. So I'm gonna plug in 3 into my derivative. What's 2 times 3?
6.
And 4 minus 6 is? I honestly, I don't actually care about what number it is, I just care the fact that it's negative. What's a number less than 2? So if I plug in 1, what's 2 times 1? And 4 minus 2 is a positive. So we know that f prime is positive on that side. And this value of 2 that we drew in here is what's going to split up our intervals. Over this way we have negative infinity, and over this way we have positive infinity. And so where is f of x increasing? F of x is increasing what interval is f of x increasing on?
Negative infinity to 2.
Negative infinity to 2. Why? What's our justification? How do we know that that's where f of x is increasing?
Because the sign of the derivative is positive.
Right, and I would say that's more words than I need, because
Derivative.
f prime is positive. Does that seem okay? And then f of x is decreasing on what interval?
2 to infinity.
On 2 to infinity, because f prime of x is negative. So, you would have done sign charts if you did like polynomial inequalities, or like just testing where like your polynomial was above or below the axis, things like that. Does that seem familiar at all? Some, maybe a little bit. Okay, if it doesn't, that's okay. But right, what we want to do is we always want to put our critical numbers on our number line. So if you have more than one critical number, you might have more than one spots. I think it's helpful to put negative infinity and infinity, just to remember that we're like starting there, ending there, starting at 2, ending at infinity. And then you just need to pick numbers in between those and test them. And here we were testing them in f prime. So we had to plug 1 into f prime to figure out that f prime was positive there, which meant that f was increasing. And we plugged in 3 to f prime to say that f prime was negative, which meant that our function was decreasing. Oh, the light is pointed at the back of the room, which when no one's in here, made it go off. Okay, so I will go fix that momentarily. What I want you guys to do is I want you to try for A, B, and C. And you'll notice that A just says sketch a possible graph of h of x, and it gives you some information. It also tells you that h of 2 is 6. So your graph, in all honesty, will probably look different than the person next to you, and that's totally fine. Does that seem okay with everybody? Yeah? Okay, go ahead, try 4. So A says sketch a possible graph of h of x if h prime of x is less than 0 for x is less than 2, and h prime of x is greater than 0 for x is greater than 2. Sarah, what did you start by graphing?
I graphed the point 2,6 first.
Okay, here's my point 2,6, got it. And then what'd you do?
And then I had it increasing on the right side of that point.
So
So like
and-
a parabola.
parabola increasing?
Yeah.
Like that,
Uh-huh.
okay?
And then on the left side it was like it goes up also. So it's a parabola here.
So you drew it like a parabola like that?
Yeah.
Okay, so let's check and see if that works. So for x is less than 2, so this way, we have that h prime of x is less than 0, which means that h of x is decreasing. So on this section, are we going down? Yeah. And then over here, for x is greater than 2, meaning that way, h prime of x is greater than 0, which means that h of x is increasing. And are we increasing as we go that way? Yeah, absolutely. So that looks good to me. Okay. B asked you to sketch another graph that meets those same conditions. Julia, what can we do?
Well, I plotted the point again and then I did an absolute value
Okay.
kind of graph where it's decreasing for 2.
So like that.
Yeah.
Okay, and I would agree, that meets those same requirements because we've got, again, that we are decreasing and then we switch to increasing, right? How many possible sketches meet the conditions?
A lot.
What?
A lot.
How many a lot? Like 5, 100? Yeah. An infinite number. So there are an infinite number of sketches that could have met those conditions, right? Because we could have done something crazy where we had like a line switching to a parabola, right? Or the steepness of our parabola could change, or the steepness of our lines could change, right? Like we have an infinite number of possibilities that met that condition. Okay. I want you to go ahead, flip your paper over, and we're gonna quick chat about 5 for a second. 5 says determine the intervals where f of x is increasing and the intervals where f of x is decreasing. What do you need to find first?
Derivative.
The derivative. Then what do you have to do?
Sign chart.
Okay, before I do my sign chart, I need to set it equal to 0 and find my critical numbers, if we're just looking for x. And then we make our sign chart, and then we say where f is increasing and where f is decreasing. Go. What was your first step in 5?
I found the derivative.
And what was our derivative?
3x squared minus 12.
And then what'd you do?
Set it equal to 0.
And then?
Add 12 over. Divided by 3. The square root of 4. We got plus and minus 2.
And those are our, what do we call those again?
Something numbers, critical numbers.
Okay. Then what'd you do?
Then I made a sign chart.
Okay. So we need a number line. We're gonna put -2 and +2 on. I like writing my infinity and my negative infinity. Remind me that those are like what I'm gonna look for. And we're gonna look for signs of what?
I said -3 and +3.
I agree that we're gonna test those.
And then also 1 in the middle.
Why would you pick 1?
Well, either 1 or 0. I picked 1 because it was easier for me to think of 1 and 0.
That is absurd, but I'm fine with it. I'll do 1.
Okay.
But the fact that really 1 was easier for you to think of than 0? Okay. I know, 0 makes my life so much easier, but I will make you happy. I'll plug in 1. We're gonna look for signs of f prime though, right?
Yes.
And actually, maybe I should put this f prime down here. Like, that's what we're analyzing. So, Ethan, when we plug in -3, what's -3 squared?
8, no, it's 9.
9. 9 times 3 is,
18.
try that again.
9 times 3 is 27.
That I'll believe. And 27 minus 12, positive or negative? Okay. 3 squared was 9. 9 times 3 is 27. 27 minus 12 is positive. And so, where is f of x increasing?
F of x increases at -infinity to -2.
Negative infinity to negative 2.
It decreases from -2 to 2.
On -2 to 2.
And then increases again at 2.
And it didn't ask us to justify our answer, but I think our justifications are important for us to work on. So how did you know this is where f of x was increasing?
Because f prime of x was positive.
I'm gonna write greater than 0. And how did I know this was where f of x was decreasing?
f prime of x was less than 0.
Guys, those would count, if this was a free response question, these would count as full answers, and they're great, right? I don't need even to use words. I can just say f prime of x is greater than 0, or f prime of x is less than 0. I don't have to actually use the word positive or use the word negative. Make sure that you do not do your inequality symbols, though, if you're gonna write it as inequalities. If you get mixed up on greater than and less than, especially on a calc test, then just write is positive and write is negative. They will take either of those things. Okay. Okay, I want you to try this problem. I think there's some crazy things happening here. That's okay, we will go over them. Let's take, I know there are a lot of parts, but they're all pretty quick. You're just using this graph, and we're looking at this interval from A to F. So let's take, I don't know, 3 minutes, maybe a few more, but let's try this problem. Okay. 3 squared was 9, 9 times 3 is 27. 27 minus 12 is positive. And so where is f of x increasing?
f of x increases at negative infinity to -2.
Negative infinity to -2.
It decreases from -2 to 2.
On -2 to 2.
And then increases again at 2.
And it didn't ask us to justify our answer, but I think our justifications are important for us to work on. So how did you know this is where f of x was increasing?
Because f prime of x was positive.
I'm gonna write greater than 0. And how did I know this was where f of x was decreasing?
f prime of x was less than 0.
Guys, those would count, if this was a free response question, these would count as full answers, and they're great, right? I don't need even to use words. I can just say f prime of x is greater than 0, or f prime of x is less than 0. I don't have to actually use the word positive or use the word negative. Make sure that you do not do your inequality symbols, though, if you're gonna write it as inequalities. If you get mixed up on greater than and less than, especially on a calc test, then just write is positive and write is negative. They will take either of those things. Okay. Okay, I want you to try this problem. I think there's some crazy things happening here. That's okay, we will go over them. Let's take, I know there are a lot of parts, but they're all pretty quick. You're just using this graph, and we're looking at this interval from A to F. So let's take, I don't know, 3 minutes, maybe a few more, but let's try this problem. So we need values where our derivative equals 0 or our derivative does not exist. Minimums and maximums, I'll agree with that. So what are we looking at? D I'll give you. I will agree with D. Where else? E, yeah, because E is a minimum. And right, our derivative would be 0 there, our slope is 0. Where else? Yep. Use a maximum. Our slope is going to be 0 there. And there's one more. I don't think so. Yeah, it's going to be C. Because again, there's a minimum, right? And our derivative doesn't equal 0 there, but our derivative doesn't exist, right? Because that's a cusp. And remember we said at cusps, our derivative is changing, like so not even drastically, but it changes instantly from like a negative to a different negative, or to a positive, but that's like a really steep negative, that's a really steep positive, so it like jumps. Our derivative isn't continuous, it's not differentiable there, so our derivative doesn't exist at that point. Rocket, where does g of x have a relative maximum?
B, D, and does F count as well?
No, f would not be a relative maximum, but b and d are. Because for a function to have a relative maximum, your derivative needs to change from positive to negative. And at f, yes, our derivative would be positive on the left-hand side, but on the right-hand side, our derivative doesn't even exist because their function isn't there. Okay, Fernanda, where does the function g of x have a relative minimum?
I said E and C.
I would agree with that. Okay. Now, Rocket, I'm going to come back to you, mainly because this is what you were asking about earlier. Where does the function g of x have an absolute maximum?
D.
Okay. Where does our function have an absolute minimum?
A.
Yes. So relative maximums and relative minimums are where your derivative changes sign, either from positive to negative or negative to positive. Our absolute maximums or minimums can happen at those relative points, but it can also happen at our endpoints. So we always have to check our endpoints when we're looking for our absolute maximums and minimums. And we also have to check our relative maximums and minimums. For what x values is g prime of x equal to 0? Tyler.
Would be the D,
Yep.
D,
Yep.
C, D.
Close. One of those is not.
It wouldn't be C.
It wouldn't be C. Because let's answer G. For what x values does g prime of x not exist? At C. Our derivative doesn't exist at C. For what intervals is g prime of x less than 0, Sarah?
From B to C,
From B to C,
and then from D to E.
union, and then from D to E. And Kelton, where is f prime of x, or g prime of x greater than 0?
A to B,
Okay,
C to D,
C to D, and E to F. And remember that U just means union, so we're saying on this interval also, and then also on the other interval. Does that seem okay? Yeah? Okay.
Wait,
Yeah.
For G,
Yes, sir.
since the function ends at A and F, can't you say that all points before A and all points after F don't exist for G prime of X?
Yeah, but G is only on that interval from A to F, so we're not. We don't need to say that, because we're only talking about that interval, so I don't care what happens outside of it. Does that seem okay? Okay. An absolute minimum, no, an absolute maximum is the highest point on an interval, and an absolute minimum is the lowest point on an interval. These points can be located at, what did we see? There are two types of points that these can be located at. Where did we find our absolute maximum and our absolute minimum?
The highest and the lowest points.
Yes, but not doing a good job of answering this, or trying to get you to answer it. Yeah. Okay, so when G prime of X either equals 0 or does not exist, what do we call those types of points? Okay, so these points can be located at critical points, which is where your derivative equals 0 or does not exist. Right? And that's where, like, we had the absolute maximum at D. But our absolute minimum wasn't at a critical point, wasn't at our relative maximum or relative minimum. Where was our relative minimum found? At A, which was what? It was an endpoint on my interval, right? So it can either, our absolute maxes and absolute mins can either be located at critical points or at endpoints. So we are going to, in some ways, deal with absolute maximums and minimums very differently than we deal with relative maximums and minimums. Relative maximums and minimums, right? And I'm gonna actually, let's write this down. So a relative max or min. We're gonna look for that sign change in f prime of x. For a max, f prime would go from, f goes from increasing to decreasing, so f prime goes from positive to negative. A min, f prime would go from negative to positive. But when I want an absolute max or min, we want to actually look at, or look for, our highest and lowest values of f of x. And we're going to check for that at our critical points and at our endpoints. So a relative max or min, we're looking for that sign change in f prime. Does our derivative go from positive to negative, or does our derivative go from negative to positive? When I'm looking for an absolute max or min, I'm looking for that highest or lowest point. I don't actually care what happens with f prime. I just need to figure out what are my highest and lowest values of f of x. And I have to check for that at my critical points and at my endpoints. So, let's do an example. 7 says find the absolute extrema of the function on the interval and their corresponding y values. So, we have f of x equals 2x cubed minus 3x squared minus 12x on the interval -2 to 3. Peyton, do you want to deal with critical points or endpoints first? Okay, so when we look for critical points, what do we need to do? I love it. And what's our derivative going to equal to?
6x minus 6x minus 12.
Okay, now that I've taken my derivative, what do I need to do with it?
So it equals 0.
And if you have 6x squared minus 6x minus 12, do you notice anything about that? factor out a 6, and we would have x squared minus x minus 2. What multiplies to negative 2 and adds to negative 1, guys? 1 and 2. Which one's positive, which one's negative? The 2 is negative, the 1 is positive. So we get x equals negative 1 and x equals 2. And here's where using proper vocabulary might help you out a lot. What we care about are our critical points. Have we found our critical points yet?
No.
What have we found?
Critical numbers.
We found our critical numbers. We want our critical points. So I need to do what with my negative 1 and my 2? Plug it back into f of x. So f of negative 1 is 2 times negative 1 cubed minus 3 times negative 1 squared minus 12 times negative 1. And you might be tempted to go, Hartman, can't I just plug this into my calculator? But they're not ever going to ask you an absolute extreme problem on a calculator because you could just look at the graph. They're going to make you do it by hand. So we want to practice that. Negative 1 cubed is what? Negative 1, and negative 1 times 2 is?
Negative 2.
Okay. Negative 1 squared is
1
positive 1, and positive 1 times a negative 3 is?
Negative 3.
And negative 12 times a negative 1 is?
Positive 12.
So 12 minus 2 is 10, minus 3 is 7.
One. Oh, yeah, that's negative, yeah.
Yeah? I did it in the order that made my life better, not worse.
I just thought, I didn't see the negative in front of the 2, so I was like, isn't it 12 plus 2?
Fair enough. Okay, let's throw in 2 to find our other critical point. We're gonna have 2 times, I guess I should write f of negative 1 equals. Okay, 2 times 2 cubed minus 3 times 2 squared minus 12 times 2. 2 cubed is 8 times 2 is 16. 2 squared is 4 times a negative 3 is negative 12. Negative 12 times 2 is negative 24. And we get
Negative 20.
16 minus 36, so negative 20. Okay, so here are our critical points. We're not done. We found our critical points. We want absolute max and absolute min. What else do we have to find besides our critical points?
Endpoints.
We need to find our endpoints. So how are we going to find our endpoints?
Plug in, yeah, negative 2 and 3.
Plug in negative 2 and 3 back into our f of x. So f of negative 2 is 2 times negative 2 cubed minus 3 times negative 2 squared minus 12 times negative 2. Let's see. Negative 2 cubed is negative 8 times 2 is negative 16. Negative 2 squared is positive 4 times a negative 3 is negative 12. Negative 12 times negative 2 is a positive 24. So we get an f of negative 2 is, let's see, that's negative 28 plus 24, so negative 4. And then we also have to plug in 3. 2 times 3 cubed minus 3 times 3 squared minus 12 times 3. 3 cubed is 27 times 2 is 54. 3 squared is 9 times a negative 3 is negative 27. And negative 12 times 3 is a negative 36. And we get that f of 3 equals 27 minus 36 is negative 9. So there are our endpoints. And it asked us for the absolute extrema, their corresponding y values. So, where's our absolute max going to be? Or what is our absolute max and what is our absolute min? Okay, our absolute max equals 7, and that happens at x equals -1. And our absolute min is -20, and that happens at x equals 2. So in this case, our absolute maxes and mins just happened at our critical points and didn't happen at our endpoints, and that's kind of annoying that we did all this work and we didn't have to. But it happens, yes. Oh, it is Wednesday, and we're not doing bells, huh? Okay, all right. Hopefully that feels okay. You guys have to go to crew. That's where you're going. Yeah, make that face.